Okay, everyone. So, welcome to this module of load balancing and scaling. So, we are going to discuss majorly two topics over here regarding load balancing. What is load balancing? We'll try to understand that first, and later we'll try to understand that what are the services or how many types of load balancers are being offered to us on AWS. Apart from that, we are also going to learn about scaling. So we have been talking about auto scaling since so long. So what is auto scaling? There are two types of scalings basically, vertical scaling and horizontal scaling. So we would be discussing about these generalized concepts as well as we'll be discussing about the services that are given to us on AWS for doing such tasks. So let's get started and see that what we are going to understand. So these are the only two contents that we will be discussing in this particular module. So under load balancing, we are going to understand ELB, that is Elastic Load Balancer. This is a service offered to us by Amazon for load balancing. And there are different types of load balancers that we are going to understand. So the very first question that comes into our mind is that what is load balancer? So load balancer is nothing but a networking component. It is a part of networking. What it will do? It will distribute the incoming traffic across multiple servers or resources to improve the availability, scalability, and reliability of the applications or services. So, this ensures that no single server becomes overloaded and that traffic is only directed to the healthy servers. For example, if I have 3 EC2 instances on which my application logic is running, or these 3 are the app servers. I do not want my first app server, to be any one of this app server to be overloaded with the requests. So what we can do is we can have one front door entry over here with the help of ELB. So all the requests which are coming from the net or web would be going here to the ELB first, and then ELB would be distributing the load accordingly to different EC2 instances. It also provides us with the features such as sticky sessions if we just want to redirect all the requests generated by one user to one of the instance. We will be discussing about that later. So load balancers can be implemented at different layers of OSI models. You can have your load balancer on network layer. You can have your load balancer on application layer, right? So load balancers can be either hardware based, software based or cloud based. So we would be talking about cloud based because we have this course of AWS, right? And they are also getting, popular nowadays. So load balancer is basically one critical component of modern application architecture and it is essential for ensuring the higher availability. So if in case this instance goes down, it becomes unhealthy due to some of the reason, then load balancer will stop sending traffic to that. It will send the traffic or distribute it between two healthy instances that we have so that customers do not face any kind of issues. So the next topic is ELB. So Elastic Load Balancer is managed load balancing service which is being provided to us by AWS. It will automatically distribute the incoming traffic across multiple targets. The targets can be EC2 instances, it can be containers, or even the IP addresses. It provides us with fault tolerance, high availability, scalability for our application by automatically distributing the incoming request to multiple targets on the basis of load balancing algorithms and health checks. It does health checks as well. So it will be distributing the traffic across healthy targets and detecting and rerouting the traffic away from the unhealthy targets. It can also load balance between different lambda functions. So this is the basic introduction of our load balancer. Now if you try to look at this diagram, then you will be able to easily understand that we have, multiple requests coming from the internet. So this load balancer is web facing, right? This is the elastic load balancer would be accepting all the incoming requests from the internet, and it would be balancing out that load onto different EC2 instances. And as you can see over here, it is working cross availability zones. So it can span across availability zones. You can have your EC2 instances into multiple AZs, and load balancer can balance out the load between multiple AZs over here. So there are three types of load balancers that we are going to discuss. The first type of load balancer is application load balancer. So it works on layer 7 on OSI model. It is designed to route the incoming HTTP or HTTPS traffic to different targets. The targets can be EC2 instances, it can be containers, or it can even be Lambda functions. So it is ideal for modern web application that require advanced features such as content-based routing or let's say WebSocket protocol or HTTP2 support. Because it can support multiple protocols. It supports HTTP 1.1, HTTP 2 and WebSocket protocols, making it suitable for modern web applications. The content-based routing means ALB can route the incoming traffic to different target based on application content such as URL path, host name, HTTP header or any kind of query string parameter that can be attached. So according to these parameters or according to these content, it can route the traffic to different targets. It also have advanced routing capabilities. For example, routing can be done on the basis on URL redirects, priority rules, container level routing for application running on Amazon ECS. It also have native support for containers, so ALB can integrate easily with ECS, that is Elastic Container Service on AWS, that we are going to discuss further in our course, and also with Kubernetes to provide native support for container based workloads as well. It is secure, so it supports the SSL and TLS termination. It supports client authentication, and it also can integrate with AWS Certificate Manager to enhance the security of your applications. The next thing that we are going to discuss, or the next type of load balancer that we have, is network load balancer. So when we talk about network load balancer, it would be working on the network layer, that is layer 4 of OSI model, and it is designed to handle high volumes of the traffic, and it can route the traffic to multiple IP addresses based on TCP UDP protocol. So the protocol for ALB was HTTP and HTTPS. For NLB it would be TCP UDP because we are changing the OSI level. Now why this is faster than ALB is because, so when we look at the OSI model, okay, it is the 7-layer OSI model. So at each layer we do add the headers. Okay, so as we go up, the headers are being appended. So the very first layer, let us just discuss that briefly about the OSI levels. Okay, the very first layer is the physical layer, where we are basically responsible for transmitting the raw bits, okay, over the copper wire or optic fiber. On the physical layer, we have the data link layer. So the data link layer is responsible for framing the data into packets, adding the headers and trailers to the data. Then we have network layer. Okay. So network layer is responsible for routing the packages between different networks using logical addresses such as IP address. So it will be responsible for identifying the source and destination. And NLB works at layer 4, that is our transport layer. So the transport layer is responsible for establishing a reliable end-to-end communication between two devices using protocols such as transmission control protocol or TCP, or we can have UDP as well. So it ensures that packets are correctly delivered in order without loss or duplication. So NLP works here, right? On the top of transport layer, I don't have any space here, so I'm just putting it right over here, okay? We have session. On the top of session, so basically session layer is responsible for managing the communication sessions between the applications, right, including session establishment, maintenance, termination. So what it will do, it will allow us to provide the, or it will provide us the services such as synchronization, checkpointing and recovery. Then we have the presentation layer. So if we talk about the presentation layer, it is responsible for translating the data between the application format and the network format, including data encryption, compression, or conversion. And lastly, at the top, the seventh layer is the application layer, where ALB works, that is our application load balancer. So this layer is responsible for providing application specific services to end users such as email, file transfers, web browsing, and it uses the protocols such as HTTP, HTTPS, FTP to communicate with other layers. So as we go up, okay, from the first layer to the seventh layer, all the way up to seventh layer, headers are being added. Okay, right from data link layer, the headers would be added or appended with the data. So you can see that at the network layer, we would be having the header of data link layer, the header of network and the data. On the transport layer, we would be having three headers and data. Right. So you can see that if we go up to the application layer, the headers that would be appended would be, more in count. So that's why ALB is, it is also able to maintain, multiple or high volumes of traffic, but not like NLB. Because the count of header at the fourth layer is less, that's why it would be handling high volumes of traffic efficiently. So when the application require ultra high performance, then at that time NLB is really very efficient because it is able to handle millions of requests per second with low latencies and high throughput. It supports TCP, UDP, and TLS termination for secure connections. It uses the static IP address for the load balancer, making it easy to integrate with external clients or services. It also supports cross zone load balancing. So basically, also ALB does that, right? That's not the issue. Health checks are being performed. So these are some generalized, advantages of the load balancers. Apart from that, we have the last type of load balancer, that is gateway load balancer. So, gateway load balancer allows you to deploy, scale, and manage third party virtual applications. Right. So, it is again a fully managed, scalable, and highly available network service which is being provided by AWS. It can manage third party applications like firewalls, IDPS, that is intrusion detection and prevention systems, and other security and networking appliances in your VPC. So it is scalable. So GWLB, or say Gateway Load Balancer, is designed to handle millions of requests per second, and it is ideal for high traffic applications. It is highly available with automatic failover across multiple availability zones. It allows you, or it supports the third party virtual appliances, including those from vendors such as Checkpoint, Fortinet, Sophos, etc. So these are the different types of load balancers that we have and different kind of applications that can be supported using different types of load balancers.